Let's do another example. Suppose you begin saving for your retirement by depositing $2,000 per year in a retirement account. These days, the best rate you can get is around 3% per year. How much will you have in 40 years? So actually, let's click on this. That's something I found, for the investment accounts. So that's actually a very recent summary of interest rates, February 2019. And if you scroll down, it gives you different banks and what they offer if you deposit money for a long term. And you would see that, for a longer number of years that the money gets deposited for, the interest rate is somewhere around, 3%, a little bit more, a little bit less. So let's make it, kind of easier and say 3%, which is what I did. So you're putting $2,000 per year in a retirement account. You will expect to earn 3% every year on the money that you have. And the question is, how much will you have in this retirement account after 40 years? This question is asking you to find the future value of this annuity with 40 identical annuity payments in the amount of $2,000 each. So following the formula to find the future value of an annuity, you do 2,000 multiplied by 1 divided by 0.03, the interest rate, times open parenthesis 1 plus 0.03 raised to the 40th power minus 1 close parenthesis. This gives you $2,000 times the entire second complicated term is 75.4, like the multiplication factor. You can, for example, find it in table 4 at the end of the textbook, or calculate the whole thing by hand, or using a calculator that allows for parentheses and all that. The answer is $150,802.52. And in the financial calculator, let me bring it up, you would do the following. Let's clear everything just to make sure nothing gets messed up. So $2,000 is going to be repeating. When you know something is repeating, that's PMT, the payment. 2,000, make it negative. PMT key. The interest rate is 3%. 3 IY. We have a total of 40 identical deposits. So you put 40 and compute FV, future value. 150,802.52. Again, notice how much of a difference the interest makes. So if you didn't know this formula, the easiest way you would be trying to solve it is taking 2,000 multiplied by 40. That would be what? That would be $80,000, right? 80,000. We have almost double that. We have 150,802.52. So the rest is all interest earned over the years. Another example. You decided to start saving and depositing $1,000 in the end of each month. The best checking account rate you can find these days is 2% per year. Actually, let's click on this link I found. Bankrate.com. Again, we have different banks, like a lot of online banks, and it shows the interest rate you earn on checking accounts. So we have 2.02%, 1.25%, and then very low percentages. They're actually ranked highest to lowest. So the highest is 2.02%, right? Let's make it easier and use 2%. So 2% per year. Your bank will be adding interest to your account monthly. You will be making these deposits, right, 1,000 at the end of each month, for exactly 2 years, until you graduate from Cal Poly. How much money will you have in your bank account 3 years from today. This is actually a pretty complicated problem. First, let's see what's going on. Let's draw our imaginary timeline that goes into the future. And there are 3 years in the future that are important. For the first 2 years or 24 months, you will be making the deposits in the amount of $1,000 each at the end of each month. So at the end of the first month is where you put the first $1,000. At the end of the 24th month, you put the last one. We have a total of 24 of these $1,000 months. The first step would be to find the future value of this annuity at the end of it. So at the end of the second year, after, which is when you stop making any further deposits. So how much do you have at the end of 24 months? And then, because the question asks us to calculate how much you'll have in your account after 1 extra year, you would then need to take the answer you get in step 1 and find its future value. You treat this answer from step 1 as a single cash flow, kind of going back to chapter 5, right? And you find its future value after 1 more year, except you should keep in mind that the interest is earned monthly, so you would need to find the future value after additional 12 months. So your N would be not 1, but 12. So in the first step, we want to find how much money we will have in our account at the end of the second year, which means at the end of 24 months. So 24 is what we're going to use for T in the future value of an annuity formula. Because deposits will be made monthly, everything should be reflecting the monthly frequency in our formula. For example, we already know that the number of cash flows should be 24. The interest rate should also be monthly. To find the monthly interest rate, you take 2% annual rate and divide by 12, and you get 0.1667%. This is a little bit rounded because it's actually 0.16666 and it just keeps going. It's sixes. When you use this monthly rate and 24 for the power in the future value of an annuity formula, you will get $24,465.67. And of course, you can do it in the financial calculator. How do we do that? Let's see. I already cleared everything, but let me do it again. 1,000 is going to be repeating. Make it negative and save it as payment, PMT key. How many times will it repeat? 24 times. Put 24 N. You need to use the monthly interest rate, which is 0.1667. We rounded it a little bit, right? And you press IY, compute future value, 24,465.77. On my slide, it's 67 cents rather than 77. On my slide, the number is more accurate because I used Excel to do the math, and Excel kind of doesn't round the numbers in intermediate steps. So the Excel actually used the more accurate interest rate where it's sixes, never ending sixes. Then the second step. What do you do in the second step? In the second step, you let's say you get kind of lazy. You're like, oh, I know that in the second step this will be my present value, so why don't I just, save myself some time and right away press the plus minus button to make it negative, and then PV. So now I'm at the beginning of step 2 of my calculations. Then I do 12 months. The money sits in the account for 12 more months, 12 N, and keeps earning the monthly interest of 0.1667%. Press IY. Compute future value. Oops, I'm really off. This is not what the slide shows. I got $37,070.33, but the slides show that I should have $24,959.50. Which one is right? The financial calculator made a mistake. What's on my slide? The lower number is actually correct. So what did I do wrong with the calculator? The mistake is that I did not clear the calculator's memory. I should have cleared the calculator's memory and then did step 2. In other words, I shouldn't have, done it the lazy way. And what happened is that the calculator thought that I continue having $1,000 deposits at the end of each month during the 3rd year in step 2. But this is not what's going on, right? My PMTs were essentially 0 during the 3rd year, but the calculator used $1,000 for the payments. And so what I should have done is I should have cleared everything and then started from the beginning. So at the beginning of the 3rd year, we are now starting step 2 calculations. We have $24,465.67. Negative PV. 12 months later, 12N, at the monthly interest rate of 0.1667%, press IY key. How much will you have? Compute future value. Now the answer matches my slide's answer, except again there are a few cents by which our answer in the calculator is off. That's again the rounding error, because it's using the rounded monthly interest rate, and on my slides the number with 50 cents is actually obtained through Excel, where nothing is rounded. So this is more accurate. In other words, before doing step 2 in the financial calculator, you need to clear the time value of money, either second FV or full reset, second plus minus enter. Either way would do the trick.